Okay, so day 68, we are doing our day with polar equations, and we're three shapes: lines, spirals, lemniscates. So new equations, what are they? First of all, a real line, okay? Our radian value, and theta is equaling some a, which is, you see here, some radian. So what happens when theta is, no matter what r is pi over 3, and the same thing all the way down. What happens? Well, let's graph it. Let's mark pi over 3, theta at pi over 3. Now let's graph all these points are theta. So we're going to, remember when we do this, we kind of do it opposite. We go, what if theta is this and r is negative? Theta is, oops, I'm on the wrong radial. There we go. Sorry about that. Not that one, that one. Okay, along the radial. Theta is pi over, r is negative 2. Theta is pi over 3, r is 0. Theta is pi over 3, r is 2. And here we have, look what happens. That's how we get a line. So anytime you see the equation of the form theta equals a radian, you know that it's a, okay? So what I want you to do is, let's do number 1 down here together. You can do number 2 on your own. And I say, okay, theta equals 11 pi over 12. I mark my 11 pi over 12 radian value. It's over here, 11 pi over 12. And I know that the equation will be just the line along the. Okay? All right. You can do that one on your own and check with Mr. Raymond. Okay, let's move shape. Spiral. Spiral equals r equals. All right, how does this work? Well, you see what's happening. We're graphing points are theta, a polar plane, but as we change theta, as theta moves along, what is happening to r if the equation this, r equals a, some constant. Let's make a 1/2 theta. So what we've done is we've said a equals half. Well, what does that graph look like? So everyone to get out your calculators. Now we're going to input a polar, we haven't done this yet, so to y equals, and I've changed it already, so everybody hit the mode button. Go to mode. We need to make some changes. Okay? Select here a teeny bit. And there we go. How's that? All right. So we need to go down 3, and you have radian or degree. You want to be in radians because we're going to input radians. And then go down to the 4th level line, and you're going to hit polar. We usually live in function mode. This is parametric, polar, sequential. We want polar mode, okay? Those are the 2 changes you may need to make in the mode. Now I'll go back to y equals, and that's where how you get r equals a polar equation. All right, so what we want to do now is we have to go to the table. So everybody hit the blue key. We're going to go to set the table. Blue window, okay? Blue key window. We're going to start the table at 0, and then for the change in the table, what are they doing? They're going up by pi over 4. So for change in table, we need to put in pi divided by 4. Now, it's going to give me a decimal, but all this decimal represents is 3.14 divided by 4, which is 0.78. Okay? So this is just 0.78. Okay, and that's how the table is going to go up. All right, so now we've put that in. Let's put in we've put in the equation. We got to put in the equation. The equation is 1/2, so we'll say 0.5. Now instead of putting an x in, we're going to put in a theta, and there it is. It's the same button. Okay, can you see that right here? The same theta button. Okay. So we're going to put in 0.5 theta. Now let's go to the table, second table. Okay. So we're changing our thetas. There's 0, and what is our r value? As theta of an 8 or pi over 4, we get 0.4. Well, let's go down to pi. Pi over 2 is 1.57. Radian value, what is r? 0.8. 0.8. We go down to, let's go to, our table goes next to pi. There's pi, and what do we get? 1.6. I'm rounding. Now we're going to next go to 3 pi over 2. It is 4.71, and that's just 3 times pi divided by 2. Now, r 2.4. Now go down to 2 pi, 6.28. We get an r value 1.4. Okay, so we put it in equation. We created a table. And don't forget, we changed the mode to radian. All right, let's graph that. What does it look like when we graph it? All right, 0, 0. There we go. 4.4. So I go to pi over 4. See what these are. Pi over 4 is up here. Pi over coming out 0.4. Next, I'm going to go to pi over 2, and I'm going to come out at positive 0.8. Okay? Now I'm going to go around to pi, right? I'm plotting r and theta. So to theta, and I come out 1. And then I go to 3 pi over 2, around to 3 pi over 2, and out to 4. And then around to out 3.14. So you see what's happened. Now let's connect this. So this is where I started, and it looks like this. And what we call this is the spiral of Archimedes, because Archimedes started this spiral. And let's remember the structure of the equation. R equals a number theta. Okay, up here is theta equals a, or a number. Theta equals a number. All right, let's go to the back. I stop the tape, and I want you to plug r equals 2 theta into your calculator. You've already, well look, you got a setting so that the table set, blue table set, and then you're going to start at 0, and over 4, you're going to go up by pi divided by 2. You're changing the table, and that just means the scale. And you got a plot of 1/2 in there. All right, so do that, graph it, and see the difference. Here we have. Compare this to when you change the a value to a number. All right, stop the tape and do that, and then check your answer. All right, shape is a lemniscate. What is a lemniscate? Well, it's an equation is r squared equals a squared cosine 2 theta. So it's not r equals, it's r squared. That's how it's easily identified. It's also r squared theta. Another thing is that instead of a theta in here, we have a 2 theta, like our roses, a b value. But this case, r is squared, and n is always 2. Okay, so lemniscate equals 2, and you've got an equal equation. Well, what does it look like? Well, it looks like an infinity sign, or figure 8. We see the correlation that when you have a cosine graph, it's anchored on the x-axis. When we have, it's always anchored on the line pi over 4, or 45 degrees. Okay? Now, how does the a value come into play? Well, let's look. What it is a squared, like let's say this is t5. Then from the origin to the end here will be the value a, the square root of this term, whatever it is. So the length here to here is also a. Let's see what this looks like in equation. All right, r squared, we know it's a lemniscate, equals 16 cosine 2 theta. Good. Well, what is a? A is the square root, which is 4. It's a cosine graph, so it's going to be along the x-axis. So I just plot here, 1 here, and then I draw what I basically is a figure 8, right? That's r squared equals 16 theta. Let's look at the next graph. Well, we know it.
If you are the driver of a silver in the parent loop, it is about to get ticketed and towed. Please move your car immediately to your Honda in the parent loop that needs ticketed or towed. Thank you.
Okay. So what I sign graph, that's why I drew this line, drew the radial pi over 4. Now I'm going to a value. A equals the square root a equals 5. So I plot and then I come out 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay, and I have the same shape. There we go. And those are your two options. Lemniscates. Next class.